Hi everyone, thank you for joining me for grade 12 math. The chapter that we're going to be doing today is transformation. But before we get into transformation, we're going to do a review on relations and function. As you can see on the board, we have two different types of terminology. So we have relations and we have functions. Okay? So we're going to get into relations first. So first we're going to talk about relations. And I have pre-written all the information on the board. And the reason I did that ahead of time is so that we can have an idea of what is going on without me having to waste time to get into these two different definitions. Before we work with the transformation of functions and their related equations, it is important to review what is meant by relation in this case and function over the other side. So a relation is a set of ordered pairs. So that's the first thing. A relation is a set of ordered pairs. And we're going to look at that. What does that mean? Second part of the definition is every graph is a relation. Okay, so bear that in mind. So the first element of the ordered pairs, it's called the domain. Okay, so that is the first elements of the ordered pairs. It's called the domains. The second elements, okay, is called the range. Okay, so we'll get into that after. So here we have it. So the description in words is one way of expressing relations. So I didn't write this out purposely because I wanted to write it here. So when we're looking at output numbers, when we're describing in words what we're going to be doing, for example, this is just an example of what you will see in words. An output number is such that the input number is, just writing it on the board now, is multiplied by 2 then add 1. So this is how you're going to see that in a sentence. So you can, in a relations expression, you can actually see it in words like this. So that would be the first way to express relations. The output is such that the number, which is the output number, which is the result of what you're going to be finding, that input number is the starting point, is multiplied by 2, and then you add ADD 1. Okay? The second way of expressing a relation, we're still on this side, is where you express it as an equation. And the equation is y equal 2x plus 1. That's exactly what I said here. I said the output number is such that the input number is multiplied by 2, then add 1. And this is what it looks like when it's in an equation. That input number is multiplied by 2, and then you add 1. And remember your BEDMAS. Always have BEDMAS. You should remember that. You always do your multiplication before you add. Okay? And this is just a little bit of a review. BEDMAS is first you do your brackets, which is B. Then you do your exponents, which is like power, when you go to the power of something or a square root of something, then you go into the division, then multiplication, then addition, then subtraction. Addition and subtraction doesn't really matter, to be honest. And also division and multiplication doesn't really matter because these are interrelated. So division and multiplication can be done anytime, and adding and subtracting can be done anytime, but this is just for simplicity. BEDMAS, bracket, exponents, division, multiplication, addition, subtraction. That's just a sidebar. So in regards to the equation, you must multiply first that x, then you add 1. You cannot add before you multiply the variable, unknown variable. Now, the third way of expressing relations is by a set of ordered pairs. So in this case, we have 0, 1. That's the first ordered pair. And remember, your x comes first. So this 0 represents x on the x-axis. Okay, the value of x. And 1 represents y. And you continue for each one. X, y, x, y. Always remember that. And I'm sure grade 12 students would know that. So you always have x, then y. And another way of expressing the relations is in the table of values. So if you notice, everything I have here, I have it in this table. So when you have x, the x values, 0. See, here's my x, 0. X is half, which is this one over here. X is 1, which is this one here. And x is 2, which is that one here. And then you can go into y, the value of y. And if you input that information in this equation, you're going to find that the answer is correct. For example, if x is 0 for this equation, 2 times 0 is 0 plus 1. That's your value 1 here. That's why y is 1. If x is a negative a half, 2 times a half, right, is equal to 1, which is negative 1. Okay? And then your negative 1 plus 1 is equal to 0. When x is 1, 2 times 1 is 2, plus 1 is equal to 3. When x is 2, 2 times 2 is 4, plus 1 is equal to 5. So you can see they all are related. In terms of a graph, you can use this information here to plot your graph. You can just simply go to this coordinate, which is also another way of expressing this information. These are coordinates, okay? So 0, 1 can be found when x is 0. So remember, this is the x-axis, and the y-axis is the vertical, okay? I don't have space, but this is the y-axis, and this is the x-axis. So you will find your x-axis values horizontal, okay? So you'll be counting as though you're using like a number line. So this is the origin, which is 0, right in the middle here. So that's your 0. And 0 works for vertical and for a horizontal. So if 0 is here, that means you cannot be on the right side or the left side on the x-axis for this coordinate right here or this pair. So when x is 0, y is 1. And guess what? 1 is above the x-axis, and then any negative values of y will be below the x-axis. And this is supposed to be negative 2, and this is negative 4. Okay? So, which means your point will be right on the vertical line, which is the value of x, that is 0, and then your 1 will be between 2 and 0 right here, okay? And then we'll just skip that one, and then we'll go to 1 and 3. As you can see, when x is 1, Okay, right here. You can just do an imaginary line. When x is 1, y is 3. Okay, you can see that. And then when x is 2, y is 5, which is somewhere up here, okay, in that direction. So you can see the graph is not exactly accurate in terms of drawing because I'm just using freehand. But if you use a ruler, if you use a graph paper, you'll see what I'm talking about. And the other side too, when y is 0, x is negative a half. So you're going that way. See that? So which is this value here. When x is negative a half, which is right in the middle here, y is equal to 0 because it's right on the line. So this is what this is. I skipped that one. And you can use your pairs to plot the graph, or you can use your table to plot the graph. Okay? Now let's go over to functions. So there is a different way of expressing functions in opposed to how we do relations. So the definition of functions, they're special kind of relations. They are relations, but they're special. They're not just like those over there. So for every valid input number, there is a single output number. Let that soak for a moment. For every valid input number, there is a single output number. So every valid input number, that would be x, okay? And the output number will be y, okay? So which means for every x, there can only be one y. So example, when y is equal to x squared, only one value can be y, which means if x is -2, y must be 4. That means 2 squared is equal to 4. So you can only have one value of y. And we will go down here and see how that makes sense. So another thing to note is that when x is equal to y squared, this is not a function. Not a function. And the reason why is because you can have y can be equal either 2 or -2. So while it works this way, it doesn't work that way. See that? Because you can only have one value of y. So if x is 4, that means y can either be 2 or -2. And that's not accurate when it's a function, because this definition will cause this not to be a function. So let's go back into what the definition of functions is. When you have a domain of a function and f of x means function, all values of x must work, right? So in the sense of this variable, which is x, it must be independent. It's not relying on your y. So the domain is when all the values of x, it makes x work. So the independent variable must be x. The range, however, is such that the set of all possible output numbers is the value, which is all the y. So in this case, that's why this is what a function is. And this is what I'm explaining. So y would be the range, which is the values of all the results after you input the value for x. So x is always independent, y must be dependent. You will never be able to find y without finding x first. Okay? So x must be determined, and it must be the input number. And then once you input x, you will find y. And that's basically what this is saying. So in a graph, like such as this, you can see that at this value here, where x is 4 and y is -4, negative over here and negative over here, it's such that there can be no other value beyond this point. That's why this is a circle. That's what this means. That means it will not go further. It stops right here. And when you have the arrow here, it means it continues infinity. So how do we describe this? It's described such that the domain of x will always be less than 4, because 4 is the maximum of x. Okay? And again, this is your x-axis. And this is your y-axis. And this is your x. Okay? So your range of y will never be less than 4, -4, which means it will always be greater than -4. So if you can see the arrow is going that way, it's going more vertical, and the lowest or the minimum value of y is -4. So it will never go past -4 for all values of y. And all values of x will never be greater than 4. It stops right here and it goes to the left. So they're actually having an inverted relationship. So when x is increasing, y is decreasing. And when y is increasing, x is decreasing. Okay? So that's it for the review. And I think I'll stop here, because so that you can go back over your functions and relations. Next time, I'm going to be talking about transformation. And this will be more in-depth. But I could probably go into a little bit of a question just to test you based on what I've said so far. So let's do that instead. So we're going to have examples of relations. And then we're going to discuss or determine the domain and we're going to determine the range. I think this is good. Okay? So, in terms of ordered pairs, which is what we talked about before, so these are the different okay. Okay, so we have 2 and 3, 3 and 5. Okay, let me use a different color. That way it's easy to read. So we're going to call that ordered pairs. So 2 and 3, 3 and 5, 4 and 6, and then we have 5 and 8. So what do you think the domains are based on the definition? It says the domain is the input number, right? The domain is the input number. So if you look on the left, what are the input numbers? The input numbers are always X, right? So let's look at all the X values. So all the X values, and that's the easiest way to say it, are 2, right? That's 2 over here. Then 3, 4, and 5. Okay, you see that? So 2, 3, 4, and 5. So if those are the input numbers, what are the output numbers? The output numbers are the ones next to it. So it's very easy. So they're Y's values. So it's 3, 5, 6, and 8. I think that's very easy to understand. So I'm not going to go over anything else in that regard. It's very easy. So examples of equations. So let me just put equations. I don't need to say examples. I already have that up here. So let's look at equations. So equations such as y equals 3, and I like these kind of equations because y equals 3, that means there's no x value. Okay? And it would be a line. I'm just giving you an idea. So it will be like a graph like this. And 1, 2, 3. And then we have 1, 2, 3, -1, -2, -3. So when y is equal to 3, it's a constant. That means there's no x value. It's always going to be equal to 3, no matter where you go. So that means it's a line that's constant. So it's that way and that way. So it's infinity. Okay? Always 3 for all values of x. Actually, there's no value of x. It's always equal to 3. It's not dependent on x at all. Okay? So this is a relation, even though it's y equals 3. And so, what is the domain? The domain, based on this equation, is they're all real numbers. That's what it is. That's the domain. Simple as that. And the range is 3. Because remember, range is always the y value. What about when x is equal to y? is there a value for x or a value for y? And in this case, you can understand that the relationship. It's a positive relationship. That's how I know I'm jumping ahead, but I'm just sharing information so you'll always remember what I'm saying. It's a positive relationship, which means every time you find a value for x, it's always going to be equal to y. I love graphs, actually. So 1, 2, 3, 1, 2, 3, 1, negative, 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 negative 1, negative 2, negative 3. Okay, so the only way that the graph will make sense, it must be a positive graph is that way. So that would be my 3. When y is 3, x is 3, y, x. Okay. And when y is 2 and x is 2. So every time you input x, it must always be equal to y. Okay. So when x is 2, y is 2. When x is 1, y is 1. When x is 0, y is 0. Same for negative 1, same for negative 2, same for negative. That means the graph will be like this. And it will continue. There'll be no stopping. And in a table, you can start at 0, 0, 1, 2, 3. 2. Okay? And if you're going in the opposite direction, it will be negative 3, negative 2, and then this will be negative 1. And you continue 0, 0, 1, 1. Okay? And it goes to infinity. So that's what that means. So what is a domain? The domain in this case is very similar to y equals 3. It's the same, all real numbers. That means no matter what number you use for x, you're always going to have y as the answer. Okay, so they're all real numbers. And guess what the range will be? If the domain is all real numbers, then the range must be the same, all real numbers. Because for every value of x, y will always be the corresponding value. As I show you in the graph, every time you input the value for x, which is the domain, then the output, which is a range, will be y. Okay? So this other one is going to be tricky. So this is saying y is equal x. And what this means is, this means absolute value. I'm sure you know what that means. So even if there's a negative out here, the absolute value is x. Okay? Whether it's positive out there, the absolute value is x. Okay? So that means it can be either a negative, but the absolute value is what we're focused on. Okay? And in that case, again, it's all real numbers is the domain. That means y will always be a real number. And in that case, the all real numbers must be greater than or equal to 0. You know why? Because the absolute value of x will never be less than 0. And the reason is because even if it's negative out here, it will never be negative inside. That's why all real numbers must be greater than or equal to 0. It will never be less. Okay? And the last one for equations is x squared plus y squared equal 1. So the domain for that, and I'm going to explain to you why. So the domain is, or maybe I should get you to figure it out. The domain for this one is -1. Just making sure I have the right. -1, which is less than or equal to x, which is also less than or equal to 1. Okay? So let's think of all the variables that will be less than or equal to less than or greater than. So x is greater than or equal to 1, and x is less than or equal to 1. So the only numbers that we can think of that are in this category are -1, okay? And then you can have 0 and 1, okay? Now you can have fractions here as well, right? You can have a half over here, or you can have -1/2. So that would be the range. And the reason why, let's prove it. If x is -1/2, right? And we're going to say plus y because we don't know what that is. Y squared. And if that's equal to 1, that means the square of a half, you always multiply the numerator and the denominator. So 1 times 1 is 1, and 2 times 2 is 4, and that becomes a quarter. Okay? So quarter plus y squared. And the reason why it's a quarter, remember, negative times a negative is equal to positive. Right? So negative times negative. So that's equal to 1. And if you want to break it down, that will be y squared is equal to 1 minus a quarter, which is 3/4. So y squared is equal to 3/4. And you can do the math. So it's possible because you'd have to square root that in order to find y. So y is equal to the square root of that. Okay? And it's possible. But if the number is greater for x, then this won't be possible. And that's what that is saying. If x is greater than 1, then that equation won't be possible. It must be either less than or equal to 1 or greater than or equal to -1. Okay? And you can put the value of x in as 1 or -1 in that equation and then solve, and you'll see for yourself. Okay? And this is also grade 12 math, so everybody should know this. So -1 greater than or equal to y greater than or equal or less than, sorry, y is greater than or equal to -1 or less than or equal to 1. So that will be the range. And the reason why that's the range is because when you solve for y, when you input x, you're always going to get a less number than 1. And you're always going to get a greater number than -1 or equal to -1. And that's the reason. Okay, because remember, the domain is the independent variable and the range is the dependent variable. So I'm just gonna erase this and we're gonna look at the graphs, which is also example of relation, and then we stop there. I'm just doing like a comprehensive approach of explaining relations and functions. And I'm also doing review of what you should already know. So if you had a graph and the equation was y equals x squared minus 3, then this is what the graph will look like. Actually, I'll change that. I'll change it to 1 and 2 just to make it better. -1, -2, 1, 2. So that will be the graph. And if you need to prove a graph, always remember that you can easily do this. You can do your table. So we have x, we have y. So I'm just going to make it even better. That way it's easier. So we have -2, -1, 0, 1, 2. Okay? So if x is -2, so -2 times 2 is +4. And if you take 4 minus 3, it's going to be 1. Okay? So basically what I did was 2 squared minus 3. Okay? If x is -1, and that's equal to 1. So y is 1. If x is equal to -1, and then you minus 3, that would be 1 minus 3 is equal to -2. So then x is -2. Y is -2, sorry. 0, this will be negative 3, because you won't have a value of x. Once x is squared with 0, or you input 0 as your value, then all of that will be 0. And then you'll go right back where you started, because this will also be negative 2, and this will also be 1. And the reason is because it's just due to the square. So whatever input you add here, it gives you that curve. Okay? And that's why the minimum value of y will be equal to 3. Okay? Negative 3, sorry. It will never be lower than negative 3. And that will be part of other conversations with regards to minimum and maximum. So this is called the minimum value. Of x, of y. Okay? Now, what is the domain of that? The domain is all real numbers. All real numbers, okay? And you'll see why y will be all real numbers which is not any less than negative 3. So it will always be greater than, and that's what I was saying here. The minimum value is 3, and this is how you express it. Okay? It will never be less than 3, negative 3. So it will be only greater or equal to negative 3, and that's the y value. So you can soak that in for a while. Okay, so we have another expression, which is another graph. So in this case, it's a circle. Okay? So we have, so I'm just going to call that negative 2. This is 1. This is positive 2. This is 1, 1, negative 2. Sorry, negative 1. This is negative 2. This is 2. Okay? Now, again, the reason why this will always be a circle is because if you were to input the values of x, I like the fact that you can actually prove what we're talking about here. So again, that's why the functions, you will always have an opportunity to put in input the numbers for x, and then you can find the value of y. Okay, because again, domain is independent, range is dependent. So if x is, so we're going to put -2, -1, 0, 1, 2. So we won't go any further. Okay. So when x is -2, and again, this equation we have to do something else, because this equation is hard to just solve it like this without rearranging it. So we have to rearrange it. We have to say x squared minus 4 is equal to y squared. So when we do that, then we can solve. So if x is -2, and if you minus that, what is y squared? Okay, so already we know this will be 4 minus 4, which is equal to 0. So y squared must be 0. Okay, so that's why when x is -2, y is 0. Okay. And I like to teach why, because sometimes people just teach or put it on the board, but nobody knows what y is. Okay. Now this one, when x is -1 minus 4, what is y? Okay, let's figure it out. So that will be 1. 1 times 1 is 1, minus 4 equal y squared. So that's -3. Y squared is -3. So when x is -1, there's no value, and the reason is because you cannot do a square root of a negative. So this is not possible. Okay? So that's why there is no value for when x is -1. So there's no value for that. And this won't have a value either, because the same thing will happen when you square 1. And that's the reason why you have a circle. So we're going to move to the next one. If x is 0, four. See again. Can you do the square root of 4? No. So there's no value for this either. However, oh, sorry, I did the wrong thing. Sorry, guys. I should have had it the other way. I was looking at it and I'm thinking, okay, this doesn't make sense. I'm just doing all this from memory. So this should be rearranged the other way. So it's 4 minus x squared equals y squared. So this will work. Okay. So 4 minus So that would be 3 equals y squared. So the square root of 3. So when x is -1, so it's 0 point something. So it's somewhere or 1 point something, okay? And that's where you have it here. And the same thing will be for this one here, because that will be the same. So this will be square root of 3. This will be the square root of 3. Even teachers make mistakes. And I'm sure somebody probably was yelling at me, oh, you did it the wrong way. Yeah, I know. Okay, so when x is 0, if it's 4 minus 0, because we know that that will be the square, equal y squared. That means y is equal to 2. And that's the reason why when x is 0, y is 2. And when x is -2, when x is 0, y can either be +2 or -2. Okay? Because remember, y is not, remember what we did before, y can either be positive or negative. Okay? So that's the reason why it's here and here. Because you can either say y, if y is -2, then the square of -2 is equal to 4. And if y is equal to +2, then the square of 2 is also equal to 4. So that's why when x is 0, y is 0. Okay? And the flip side too, when x is -2, so here we have it, 2. Okay? And when x is -2, y is 0, because this is the horizontal point where x changes from, where y changes from positive to negative. So the flip side is true, and that's why it's a circle, because you have variation of x, and this will be 0. So what can we say about this domain? We can say that it's the same, right? Because as you can see, it's a complete circle. So for every value of x, as you can see here, and you can see right here too, it can never be anything outside of, x can never be outside of -2, right? And y can never be outside of 2. So it's the same thing. So even if x is -2, y will be 0. When x is -2, y will be 0. When y is -2, x will be 0. So for all values of x, they will never be outside of this range or domain where you input -2 for x up to +2 for x. And your output will never be anything less than -2 or greater than 2. We'll do 2 more and then we're done. These are just examples of relations. And this is actually a review. And we kind of talked about this before. So y is equal to 2x. And I'm going to just do 2 graphs, okay? So I know it's going to be easier to see this way. So this is the graph. Okay. So this is -1. This is +1. Okay, so that's 1. So in this case, x will never ever be negative. That's what that means. And I said that in the previous slide. It's the absolute value of x. It will never be negative. Regardless of what's happening out here, x will never be negative. But y might be negative, right? Because this is the negative quadrant. Sorry, y would never be negative, but x can be negative because x, the value of x can have a negative out here. So when x is negative in this region, y will always be positive because this is the negative region for y, okay? And y will never be down here, which means it will always be positive. So again, this is my y, this is my x-axis. So even when x is 1, y is somewhere maybe 2 or 3, okay? We'll just call that 2. And then this would be -1 down here. So, and then when x is -1, y will always be the same value in the opposite direction, which will be 2. Okay? And what does that mean? That means for every value of x, there will always be real numbers. And the reason is because they will never be, because they're absolute values. So all real numbers. Okay? And y, I said it already, will never be less than 0. So it will always be either greater but never less than 0. Greater or equal to, but never less than 0. The next graph, which is the last one we're going to be doing, so this is like a rough graph. It's not perfect. So what does that mean? For any square root of x, that's the value of y. So we can plug that number in at any given time. But what that means is x will never be greater. X will always be greater than or equal to 0 because you cannot find a square root of anything negative. Remember that? So you'll always have the value of x will always be greater than or equal to 0. And I did demonstrate that earlier because I rearranged the equation incorrectly. So the rule is you can never ever find a square root of any negative number. So first you would have to make sure that x is a positive number and it must be greater than 0 if it's positive. And then the next thing is if x is always greater than 0, or equal to 0, that means y will never be outside of that range either. Okay? So we'll never have anything in this region or this region. Okay? Because this is the negative region for y and this is the negative region for x. So that's it for domain and function. And next time we'll actually go into exercises. So this is just a review for now. Okay? So with that said, I hope this has been informative. I hope it brings a lot of memory or renew your memory from what you have learned before. And the next time we'll go more into the actual examples of function. Don't want to extend this video too long. So that's it for now. And hope that this was informative. Okay, have a wonderful night. Take care of yourself and your loved ones. Bye.